All right, yesterday, I'm recording because they're not here, so they have something to look at.
So you can hear us?
Yes.
Oh, that's kind of cool.
All right. When we looked at the exponential function and its inverse yesterday, we started by graphing the exponential function. So let's just look again at y equals 2 to the x.
Kristen, will you take notes for me?
Yeah, I got you.
Cool.
If we do an xy chart on y equals 2 to the x, if x is negative 2, what's y?
7. Write it down.
7?
She's like scrub. It'll be
What is it, Annalisa? 1,
7.
never mind.
0.25.
which is 1/4.
Point joining.
What if x is negative 1? What is y, Maddie?
1/2.
If x is 0, what's y? 1. If x is 1, y is...
2.
And then we said if x is 2, y is 4. So let's graph that function and then see what we can do with the inverse function. So if I graph the point 0, 1, and then this is 1/2 and 1/4. What's the domain of this exponential function?
All real numbers.
The domain was all real numbers. What was the range?
Everything greater than 0.
Everything greater than 0. All right, does this have a horizontal asymptote?
Does not. Horizontal.
Is there a value that the function approaches but never goes below?
Well, 0. 0.
Y equals 0 is a horizontal asymptote. And what's the x-intercept, or the y-intercept?
1.
Okay, so we have the point 0, 1. That's our intercept, the only intercept we have for this, excuse me, exponential function. Now, if the logarithmic function is the inverse, that means it's reflected across the line y equals x. And what happens to the x and y of an inverse function, Annalisa? They switch. The x and the y switch. So if I have the point negative 2, 1/4 on the original function, the point 1/4 negative 2 is going to be on the new function. And then the point 1/2 negative 1 would be on the logarithmic function. This is going to be y equals log base 2 of x. And the point 1, 0.
That's the inverse of the y
This-
equals
the-
log base 2x.
Yes, the point 2, 1. And the point 4, 2. So the inverse function looks like this. This is just reflected across the line y equals x. I don't see things real easily, so what I did was just switch the x and the y values. So for our inverse function, which I'm going to do in blue, what's the domain?
Everything greater than 0.
Okay, it's the range of the previous one, so it's 0 to infinity. What's the range, Zach?
Negative infinity to infinity.
Good, negative infinity to infinity. Does this have a horizontal asymptote?
No.
But what does it have?
As a vertical asymptote.
It has a vertical asymptote, and that vertical asymptote occurs at y equals 0. What's the intercept for this one?
There is no.
Liz? Okay, it's the point 1, 0 instead of the point 0, 1. It's everything just reflected across the line y equals x. So this is an example of a graph of a logarithmic function. We graphed y equals 2 to the x, and then we did the graph of its inverse function, which is y equals, it wasn't natural log, I'm sorry, it should have been the log base 2. And I can't go through that, I'm sure. So that is the graph of that reciprocal or inverse function. So let's think about what happens if we make some shifts. Okay, I'm just going to graph y, let's say that this is our function. What's the base if I don't see a base? Are you sure, Matt? What's the base? If I don't see a base, what's the base?
10.
So you agree with David? Okay. Here's the 0.10, and this is the basic graph. Depending on what the base is, it takes it longer to increase. All right, so here's our general graph. What about if I have f of x equals the log of x minus 1? How is that going to change that first graph?
It's gonna move to the right one.
Move to the right one. Why is it going to do that, Andrew?
It goes in parentheses.
Okay, because it's in parentheses. It's grouped together. So we know that this is going to move over 1. So if this moves over 1, my vertical asymptote's also going to move over 1. And I have a new vertical asymptote. What would be the domain of this function?
Everything greater than 1.
Everything greater than 1. In fact, if you want to find the domain, we set whatever is here has to be greater than 0. So therefore, x has to be greater than 1 to find the domain. So that's how that one shifted. It shifted 1 to the right. We have a new asymptote at x equals 1. Remember, anytime you're giving me the equation for an asymptote, I want to see the equation, not just a number. And it's always an x equal if it's a vertical asymptote. All right? Let's say that our function is h of x equals 2 plus the log of x. How is that going to differ, Maddie, from f of x equals the log of x?
Because the 2 is there. So
And what is that going to do to the graph?
does that make it go up?
It makes everything move up 2. So if I take that blue graph and move everything up 2, my intercept's going to change. Let's see if we can figure out how we would find out where that intercept is. Does the domain change? Domain won't change, but everything shifted up 2, and because everything shifted up 2, my intercept changes. And what's the y value for the x-intercept? Zach, what's the y value? Is he right? What did he say?
2.
2 is the y value of the x-intercept. How'd you get that?
Well,
If I'm crossing the x-axis, what's the y value?
2.
The y value is up and down. What's the y value if my point's on the x-axis?
Oh, 0.
0. So that means I'm going to set this equal to 0. And solve to figure out what my x-intercept is. So we can subtract 2 from both sides. And what I'm going to do now is rewrite this in exponential form. What will this be, Sarah, in exponential form?
Log x to the negative 2 power.
Okay, what's the base?
X?
On, have log. What's my base? 10. So it's going to be 10 to the negative 2 equals x. So my x-intercept is 1/100th.
X-intercept or?
The x-intercept. See, it's I didn't graph it exactly right, but it would be real close to the y-axis. Let's look at this function. Okay, log base 4 of x. Let's see if we can graph this function, find the domain and range, the intercepts.
Does that 4 do anything special or?
Well, that's my base, so if I wanted to, well, it will change how quickly things increase or decrease. I don't think an XY chart's going to help us much here. So let's just think about what we might be able to do to graph it. What is my domain?
No, it's gonna be, everything greater than 0.
Okay, we set x has to be greater than 0. Whatever's here has to be greater than 0. What's my range going to be, Annalisa? Negative infinity to infinity. Where's my vertical asymptote going to be? Andrew?
The, I don't know.
Sarah? What do you think, Maddie? Where would the vertical asymptote be? Look at the domain and see if that gives you a clue. At x equals 0. Because vertical asymptote's going to occur. It's kind of like a boundary for the graph. And what do you think our intercept is, Zach?
4. No? Oh.
We don't have any movement, no shifting, do we?
No.
So if we're not sure, we can set this equal to 0. So 4 to the 0 is equal to x. What's anything to the 0 power is?
1.
1. All right. So we know that this is going to look like this. But we've also named the domain, the range, vertical asymptote, and the x-intercept. You're going to do some graphing, and that's what you'll be asked to do. So let's look at some that has a shift. Okay, before we start graphing, Maddie, what's the domain?
I'm not sure.
How do we find it?
I'm not sure.
Sarah?
Would you do set x minus 3 equals 0 and
It's greater than, it has to be greater than 0. Whatever follows that log base 4, whatever this happens to be, has to be greater than 0. So that's how you can find your domain. So the domain is going to be,
4 to infinity.
well, x has to be greater than 3. So it's 3 to infinity. The domain is 3 to infinity. What's the vertical asymptote? X equals 3. Okay, because we're moving things over, that's going to change our intercept. So, but what's the range? Is that ever going to change? Would the range ever change?
Unless you have an inverse, right?
Unless we were working with the inverse function, then it would. But we're working with the log function, so the range is always
Negative infinity to positive.
negative infinity to positive infinity. Now, how am I going to find my intercept?
Make the x minus 3 equal to 0. No, you have to,
Put the
the
whole,
whole thing equal to 0.
okay, so 0 equals the log base 4 of x minus 3. So we can rewrite it as how? Matt? How would I rewrite this exponentially?
It would be 4 to the 0 equals x times 3.
And what's 4 to the 0, Annalisa?
1.
1. So x equals 4. So we have a new x-intercept. So if we're going to graph this function, we know that we have an asymptote at x equals 3. We're going to cross the x-axis at 4, and so the graph would look like this. So if we can find the domain, the asymptotes, the range is going to stay the same, and the intercepts, then it's pretty easy for us to graph. What do you think would happen if we graph y equals the log of negative x? What is that negative x inside going to do?
Make it reflect
Reflect across what?
the x-axis.
The y-axis. Inside there, it's going to reflect across the y-axis. Okay, so let's think about this. We need to figure out what our domain is here. So we're going to set negative x has to be greater than 0. So what does that mean when I've solved for x?
Has to be a positive number.
Well,
X is greater than negative 0.
okay. Well, when we multiply or divide across an inequality with the negative, what happens to the sign?
Flip it.
Oh,
It flips.
So x is greater than negative 0.
Can we have negative 0?
Oh, we can.
How about x is less than 0? So our domain is going to be negative infinity to 0. Will our range change? Range shouldn't change. What about our vertical asymptote?
No, it won't change. It'll be 0 still.
X equals 0 is our vertical asymptote. So if we set this function equal to 0, Maddie, what's the base here?
10.
10. So 10 to the 0 equals negative x. What's 10 to the 0? 1. So x equals negative 1. So what? Yes, ma'am.
So whenever it just says log and it doesn't have a base by it, it's understood that
It's 10. So let's see if we can graph this one. So we said our asymptote is x equals 0. And we're going to have an intercept at negative 1. Now, normally it would look like this. So when we reflect it across the x-axis, it's going to look like this. I mean the y-axis. And a negative in front would reflect it across the x-axis. Okay. Pause. On page 234, so all we did today was look at graphs. Would like for you to do 38, 39, 42, and let's do 45 through 50, those are matching.
They're matching.
Well, they're matching. Well, wait, 45 and 50, they're matching. Oh, okay, cool.
Well, it's 38, 39, 40, then I'm matching the graph.
Oh, okay.
Okay.